Problem number 39. Let's see what we can do with this one. Now these numbers are all pretty big, but they're all even, so we can factor out a 2. So let's take that 2 out and see what we're left with. 56 divided by 2, 28, and then the x squared. 102 divided by 2 is a plus 51x, and 22 divided by 2 is plus 11. Smaller numbers, a little easier to work with. Now we have to deal with this trinomial, so let's bring our 2 down, write our 2 sets of parentheses, anticipating we can do this. Now, we need to deal here with this 28. Well, a 28, there's quite a few ways to get a 28. Let's write them. Here's a 28 and a 1, cut in half and double. 14 and 2, cut in half and double. 7 and a 4, I think that's it. And then the 11, well, fortunately 11 is prime, only one way to get that. 11, 11, and a 1. So where do we start? Well, I'm going to start with this pair here because they're the closest together. And most of the time that works. So I'm going to try this. I'm going to go with a 7x and a 4x. Now if I do that, I have only one choice for the 11 and a 1. The question is, where do I put the 11? Do I put it here, or do I put it here? Well, let's just try something. Suppose we put it over here. Let's see what would happen. So if I put the 11 here and the 1 here, before we do anything else, let's just see if we've got a chance at this. That outer product would be 77x. The inner product would be 4x. 77 and 4, right? 77 and 4, I get an 81 if I add, a 73 if I subtract. That's not even close to our 51. This is not a good guess, so we'll cross that one out. So let's go with 2 and our parentheses. I'll still try the 7x and the 4x, but now I'm going to put the 11, instead of putting it here, I'll put it over here. So let's give this a try. I'll put the 11 over here this time and the 1 here. Now, what's this going to do for us, if anything? Look at the outer product, 7 and 44. Well, 44 and 7 is 51. Looks like we've got it. The 11's positive. These two numbers will have the same sign, which will be that middle plus sign. So let's put our plus here and claim that that is the factored form. In this problem, 43, we've got some common factors here. First of all, with numbers, there's a 12, a 4, and a 21. Well, I guess there is nothing common there. I thought there was, but there's nothing. So nothing common there, but what else can we do? Well, there's an M, and no M, so M's not common, but I do see a Q, and a Q. So I'm going to take out a Q, but the way I'm going to do this, and we did this in a previous section when we did factoring by grouping, is the first term in this group, right? I got a group of 3. The first term in this group is negative. So I'm going to take out a negative Q. So take out a negative Q. So if we take out a negative Q, we've taken out the negative. What's left? A 12, an M squared, but we took out the Q, so the Q's gone. So here's what's left. 12M squared. And now come over to the middle term here. We've taken out the negative. So 4's left, an M's left, but there was a Q, but we removed it. So what's left is the negative. We took out the negative, so what's left is a positive 4M, right? Negative Q times what will be negative 4? Well, negative times positive will give us negative. So we need a positive 4M here. And then in the last position, we're taking out a negative Q. So positive 21 divided by negative is going to be negative. So this will be a negative. Now we've already moved the Q, so what's left is the 21. Now let's see what we can do factoring this. Trinomial, we'll get negative Q. Here's our parentheses. Now with this leading 12, here's how we're going to get a 12. Right? We can get a 12 with a 12 and a 1, a 6 and a 2, a 4 and a 3. And I don't know which one I'm going to use yet, but I'm thinking that I'm going to be going with the 4 and the 3 just because they're closest together. But let's move on. We still have to get this 21 out here. And 21, well, 21's a kind of a decent number in this sense. 21 and 1, 7 and 3. Only two ways to get that. So I think what I'm going to try here is, first of all, the pair that's closest together here, that's going to be the 4m, because I got an m squared, and a 3m. And then with the 21, because this pair is closest together, I'm going to go with the 7 and the 3. Now, I know I can't put the 3 here. We've seen this before. If I put the 3 here, I'll have 3's in common. There's nothing common up here. We already took it out. So nothing common here. The 3 cannot go here. So if this is going to work, the only way it will go work is if I put the 7 here and the 3 over here. Now let's just check this outer product and inner product before we go on. 28 and 9. Okay, a 28 and a 9. Well, that doesn't work. Okay, well, we tried it, made a good guess, but that guess just does not work. So let's cross that one out. And let's try this. There's our negative q. Don't forget that one. Here's our parentheses. Now, I tried the pair closest together, and it just didn't work. I could have tried the 21 and 1, but if you try those in here, it's not going to go anywhere. Let's try the 6 and the 2. So I'm going to try a 6m and a 2m, and now I am going to try the 7 and the 3 just because that pair is closer to each other. But I'm not going to put the 3 here, because if I put the 3 here, I have 3's in common. Can't do it. So if this is going to work at all, the 3 would go here and the 7 would go here. Now let's see if this one has a chance. Here's an 18 and a 14. 18 and 14, if I subtract, I can get a 4. I think we've got it. This is a negative 21. So these two numbers, the 7 and the 3, have opposite signs. I'm going to put that plus sign, that middle plus sign, with the bigger of these two products. And the way I wrote mine, the outer product is 18m, inner product's only 14. So I'm going to put the plus sign here and the minus sign here. You can check that by multiplying it out, but I think we've got it now.